In a groundbreaking revelation that may shift our place in the universe, NASA announced detection of the first extraterrestrial signal in the direction of Proxima b, the nearest known exoplanet to our planet, just over 4 light-years away in the habitable zone of its star, Proxima Centauri. The finding sent a global wave of excitement and curiosity. Is this the time when mankind finds that it is not alone in the cosmos? The journey to this groundbreaking discovery started with careful observations by NASA's powerful telescopes, which have been scanning far-off stars and planets for years for evidence of life. Proxima b has always been the frontrunner candidate for searching for extraterrestrial intelligence because of its Earth-like features and closeness to our solar system. The signal picked up is unique and unlike anything astronomers have seen previously, a potential milestone in human history. The consequences of such a find are immense. To begin with, it validates the long-held scientific theory that life may be possible on other planets under conditions similar to those of Earth. Second, and perhaps more fascinating, it opens up the question of the character of the civilizations that may inhabit it. Are they simple microorganisms or advanced beings, perhaps able to communicate and travel interstellar distances? This Proxima b signal is not random noise or a natural cosmic event. It contains a structured repetition that indicates an intelligent source. NASA scientists and international teams are now charged with deciphering this message, trying to make sense of its content and the purpose behind it. The worldwide scientific community is buzzing with theories and conjecture regarding the likely content of the message. A guide, a greeting, a warning, or something totally unimaginable. Reports of this revelation have crossed from the domain of science to raise debates in corridors of government, social media spaces, and tables during meals on Earth. All sorts of persons are gazing at the sky with renewed curiosity, wondering if beings on some distant planet were perhaps doing so as well. How similar to or dissimilar from our reality might their own world be? How would their world be when it comes to technology and culture? The opportunities look as wide as the universe itself. Furthermore, this discovery raises a whole array of ethical and existential issues. How would humanity react if the signals are indeed from intelligent life trying to communicate? What kind of protocols would be in place for interstellar diplomacy? And most significantly, how would such a discovery alter our perception of religion, life, and our very existence as human beings? While anticipation is growing, caution is also palpable. Top scientists at NASA and other space agencies are working tirelessly to confirm the results, to ascertain that the signal is not a false positive or misinterpretation. We are at the brink of what potentially will be the most groundbreaking discovery in human history, so the next move needs to be done with care and responsibility. The world is holding its breath in anticipation of a more in-depth analysis. The discovery of an alien message from Proxima b not only advances our scientific endeavors to a new level, but also brings us together in common curiosity and hope. We may at last be on the brink of solving one of the longest-standing and deepest questions. Are we alone in the universe? In April 2019, a radio signal was picked up from outer space, namely from the Proxima Centauri system, 4.37 light-years away from us. While it might sound like a significant distance, it is the nearest star to the Sun, 3 times farther away from the third brightest star in our sky. This signal originates from a triple star system consisting of the binary star pair Alpha Centauri A and B, and Alpha Centauri C, or Proxima Centauri. Alpha Centauri A and B, the stellar companions, are close to one another and are very much like the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange hue. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is smaller, so our Sun fits exactly between them in size. But where did the signal between these stars come from? The groundbreaking Breakthrough Listen initiative, committed to the search for extraterrestrial communication in the cosmos, has dubbed this signal Breakthrough Listen Candidate 1, or BLC-1. The project, funded by around $100 million, utilized thousands of hours of observation with advanced telescopes worldwide. The signal was picked up by the Cyro Parkes radio telescope in New South Wales, Australia. This telescope was looking at the area of Proxima Centauri, the nearest star to our Sun. The signal nearly passed without anyone noticing in the huge amounts of data gathered over thousands of hours, but researchers were able to spot it as a needle in a haystack. In order for the signal to qualify as being relevant, it should possess two specific attributes. One, that it is restricted to a limited band of frequencies, as radio signals of such kind are not produced by the natural processes present in space. And two, that the frequency should vary depending on the relative motion of the exoplanet in relation to Earth. Researchers had to sift through nearly 4 million single signals received by the telescope based in Australia. After a rigorous process of filtering out and eliminating redundant signals, they discovered 5,000 unique signals, among which was one, an unexplainable signal. After cross-matching with modern radio transmitters on Earth, this unusual signal, with a narrowband technological signature, only manifested when the telescope was aimed at Proxima Centauri and was detected for 30 hours. On analysis, its place of origin was found to be Proxima b, an exoplanet astronomers discovered in 2016 via the radial velocity method. With this method, astronomers find that a star shifts position due to the gravitational pull of planets revolving around it. The star traces a tiny circle, and extremely sensitive spectrographs are employed by scientists to monitor the light from a star. The spectrum of starlight shifts slightly towards blue when it approaches a planet and towards red when it moves away from it. When these changes occur repeatedly and regularly over days, months, or years, it is accepted that the variation in light is caused by the gravitational pull of an orbiting planet. When closely examined, Proxima b proves to be quite Earth-like, with a radius 1.1 times that of Earth and a mass 1.3 times larger, suggesting that it is a rocky planet with similar density. There are, however, stark differences. The first is the position of the two planets within their respective solar systems. Proxima b is closer to its parent star by only 0.05 astronomical units, compared to Mercury, which is 0.39 astronomical units from the Sun. It would render Proxima b an extremely hot world, but given that Proxima Centauri is a red dwarf with little light, the planet gets a mere 60% of energy that the Earth gets from the Sun, keeping it within the habitable zone where life would be possible. There are billions of undiscovered planets floating around in our universe. To date, we have only known of an incredible 4,935 exoplanets and have just added 65 new planets to the list, which brought the number up to 5,000. The most recent batch of 65 exoplanets was added to the NASA's Exoplanet Archive on March 21st of this year, a major milestone in the study of planets. The James Webb Space Telescope, or JWST, is the most sophisticated telescope that has been constructed, being 100 times more powerful than the previous one. Through its assistance, we will be capable of demystifying the universe's enormous chunk. Previously, we have uncovered a vast range of planets ranging from tiny rocky planets to huge gas giants beyond Jupiter, and also extremely hot and possibly habitable planets. Among these finds, there are some planets. Specifically, Kepler 1649c is a planet whose properties are quite akin to those of Earth. Actually, it is the most habitable planet that we have discovered up to this point and potentially could sustain life. Up to this point, we have discovered 55 Earth-like planets, but we have not yet been able to research them all in depth. With our technology advancing at such a quick rate, particularly due to the James Webb Telescope, no one knows what else we will be capable of in the future. Wouldn't it be incredible to discover a planet that could sustain life? One of the main objectives of the James Webb Telescope during its first year of scientific missions is to find and study alien worlds beyond our solar system, focusing on how they form and the possibility that they contain water and biological life. Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as relate our own solar system to its origins. Webb's infrared capabilities are best suited for unveiling how planets and stars develop for three specific reasons. Infrared light can cut through dust effectively, identifies the thermal signatures of young planets and stars, and identifies the existence of important chemical components like organic molecules and water. Mid-infrared light has the ability to penetrate clouds 20 times more dense than visible light, a critical factor in viewing newborn stars that are enveloped within their natal clouds. These infrared abilities are important because they enable us to see and image the formative early stages of star formation, when dust and gas are still contracting to birth young stars. But there's more to natal star clouds than that. Young stars and giant planets both begin as enormous bloated systems that slowly contract over time. Since newborn stars heat up with age, giant planets cool down, but both radiate more light in the infrared than in visible wavelengths.